So if you have data in your cloud warehouse that you need to transform, I'm so sorry. If you have data in your cloud warehouse that you need to transform and normalize to build a data warehouse that is related to itself, you can use data build tool, which essentially for the user is just SQL and Jinja. The package itself is built in Python. So you still have to know how to manage Python environments in your computer. So it's still a fun little nightmare there for you. But data build tool, you have to be kind of comfortable with most BI tools like Looker or let's see, Mode is another one. Tableau is not really commonly used by people who are doing analytics engineering, but it is there. And you also have to be a little familiar with cloud-based warehouses. So like Redshift, BigQuery, and Snowflake are the big three, but there are some others. And you have to be comfortable understanding how the data is created and where it comes from for the business. So like Salesforce data or the raw backend data, or if you live in a nightmare, Marketo. So you just have to like understand how that data works and how like website tagging works. So it's a kind of a generalist situation.
Isabel, what kind of software do you use?
Yeah, so I live in the Python world. I work a lot with Fast API. A lot of the package that I build, which is called Vetiver, there's an R equivalent as well. So we work a lot with kind of translating machine learning models to API endpoints. So we have to know, how to use these machine learning frameworks. It's a lot of tidy models on the R side. On the Python side, I spend a lot of time looking at scikit-learn, and then that leads into Fast API. So these are all Python packages. I kind of live exclusively in this Python packaging world. So I use like VS Code. I actually sometimes use the RStudio IDE for Python. It's actually got really good Python environment management for whatever reason. It makes it super easy to use. Fun fact. So I mostly use Python. I do hang out on like AWS, thinking about like ECR, so container registries, moving things into Docker as well. So kind of end-to-end machine learning, hanging out a lot in the Python world though.
Yeah, and I guess in my position, we're doing healthcare analytics. I'm sure like the exact software is very job specific, but for our center, the main frustration we have is that we get a lot of people who only know SQL and that's it. And SQL can take you so far. But if you're really doing analytics, we want people to know either R or Python or both. Also, GitHub is very valuable for knowing how to control versioning. Yeah.
Yeah, on my side, we're doing the same like DBT SQL stack with Snowflake thrown in GitHub, kind of all the standards. I work predominantly in R on top of that. I think the one thing I'll add is like, I think when you come in data science, you're often like steered to learn Python or R. But I think what I've learned sort of over the last few years is some of the software that's most valuable for me is like really strong SQL skills and even terminal command line interface stuff. If you start getting a lot of skills in those areas to add on to the Python or the R, it takes you pretty far and you can do lots of fun things with it.
Awesome. All right, next question. What are the primary skills you use in your day-to-day work? Isabel, can we start with you?
Yeah, I can start off with that one. I'm gonna give kind of a cop-out answer. A lot of reading comprehension skills, being able to understand what people are actually asking for, reading a lot of documentation and being able to parse that as I need to. I think a lot of my job is reading and writing docs. So I would say about 50% reading and writing docs, 50% coding in Python. And it always seems like the Python part is the easier part, but being able to sit back and communicate things that are maybe second nature to me, but not second nature to the people I'm trying to explain them to is really important. So I'd say that is a primary skill for me, is communication. It's not as exciting as saying like Python and using decorators, but I think it's something that will last me longer.
Great. How about you, Julia?
Yeah, I mean, again, I assume this is very like job specific. So my interest has always been in doing scientific research studies. So we look for people who have not just the tech and coding skills, but some understanding of, scientific design, how to design a study and evaluate a hypothesis. But obviously that's only applicable to people who are interested in the scientific research world. So the day-to-day skills, I think, are going to be very specific to the kind of job you're interested in.
Cool. Jessica, or Jess, how about you?
Yeah, I feel like as I move up in the organization, my day-to-day involves like less and less coding, even as an IC. It's much more about sort of getting stakeholders to align on things, laying out sort of large scale plans for projects as we want to move forward, and then sort of laying out the technical specifications for lower level staff members to sort of execute on the day-to-day. I still do manage to code from time to time, especially as an IC. It's one of the reasons I don't want to go the management track. I want to still be able to code to some degree. But I find like, it might happen 2 or 3 days a week versus all of them now.
Cool. Marika, what are your primary skills you use in your day-to-day?
SQL, definitely. Understanding cloud warehouses, understanding how query performance, sadly, segment, knowing how to use segment, knowing how to implement tagging. I'm similar to Jess where I am an IC, but I don't like this show for some reasons, but have you ever seen the Home Edit on Netflix where they go into people's houses and they organize it? That's kind of what analytics engineering is that you go to like all your stakeholders and all the people who are using the data and you say like, what do you want to know? And then you say, here's the ideal way to store your data in a method that actually makes sense to the reports that you need regularly, or any data science activities that you want to be doing later on down the road. Or if you ever need to move off of this tool, you can switch to a different tool. That's kind of what we are there to do. We are those incredibly white women from the Home Edit. We go into people's houses and reorganize them.
Okay, great. What's next question? What steps did you take when you first started your job or career that you believe ended helping you out more than you realized? Isabel, if you want to go first.
Sure. I think in a practical sense, one of the things that helped me out a lot for Python packaging in general is I made something called a cookie cutter for a Python package, where you had to, it's like a command line tool, automatically generates all of the like nuts and bolts for this package. And I had to go through like each file, think about what would go into it, what would people be interested in, like, do you want to choose like click for your command line interface, you want to do something else? So diving deep into the package itself and kind of what is the foundation before I even put any of my code in, like what is like the wheel, the setup tools, like do you want a setup.py? Do you want to setup.config? The Python packaging world is a crazy, crazy place. There's great tools in R for how to set up packages, but that doesn't really exist in Python. So you have to make your own opinions more. So that was something that helped me a lot later, because then if people had questions about, I want to integrate my Pi, how would I do that? I would already have that knowledge kind of in my belt of why I had chosen to use certain files to make things more extensible later. And also trying to balance choosing tools that were new enough for packaging that they're still supported and like feels modern, but not so new that all of my packages break and nothing is supported anymore. So that was something that I think was super helpful for me to get a little bit deeper into what even makes up a package in Python.
Cool. Julia, how about you?
Yeah, sorry, was the question statistics packages or packages in general?
Just any steps. The question just says any steps that you took when you first started that
Those steps that
you.
you took when you first
Yeah.
started. Yeah. Yeah, I mean, I came up through some generic academic training. So I got a lot of training in research methods and then spent a lot of my career wishing that I had learned more coding skills. So yeah, definitely coding, whether it's R or Python or SQL or whatever language you choose, getting proficient in coding programming is going to be so valuable. Yeah.
Jess, how about you?
Yeah, I feel like I kind of come at it from a slightly different way. I think for me, the thing that's been most valuable throughout my career is the subject matter expertise. I came into data science sort of by accident, but with a very strong background in mental health. My PhD program was specifically diving into mental health. So for me, like that add-on of coding was obviously like a shift, but the subject matter expertise has been invaluable. And I think sometimes people focus too much on being super proficient in coding. I'm a pretty strong believer you can learn that on the way, especially if you have code reviews, good mentors, like all of that stuff. But like actually taking the time to understand your business area, whatever that may be, is going to take you incredibly far.
How about you, Marika?
I think when I started analytics engineering, I had already been a data scientist and a data analyst and an epidemiologist. So I had done other data things. For every job that I start, one of the things that I do with every company is talk to the different people who are in marketing and sales and engineering and put together like a data architecture diagram, which you'd be surprised, like nobody has. Like I'll start at a company that has like 60 people and they don't have documentation about like, here are all the tools that we use that our customers interact with or our users interact with that could potentially have data that we want to look at. And do they connect to the back end? Do they, do we use this data? Does it ingest anything from another data source? And nobody ever has these, which is wild to me. So, and every time I've done it, like every company has been like, wow, this is super useful. So this is separate from my data journey, but when I did work with Code for Philly, like we were trying to be as adamant as we could about documenting, because documentation, my saying, an ounce of documentation is worth a pound of Slack messages. So if you are just doing the work of actually documenting, like, here's the data source of this, here's how we define what a member is, here's how we define what a user is. Yeah, that's the other end of it is there's data definitions and there's business definitions, and you can't rely on the business to make your data definitions because they will not always be the same definition. But like, for example, if your user is like in WordPress, they're user type 1 because user type 2 is people who work for the company. that would be your data definition, but your business definition is anybody who has access to the platform is a user. So all of these things are kind of outside really of like my technical, because so much of what I do is not necessarily technical, it's logical problems that is just not done. It's not done before we start. And it is absolutely necessary for people to analyze a warehouse where we're trying to count users, but they don't have a constant definition of what that is. So that's usually what I start with.
Okay, good to know. Okay, next question. How much do you feel like your day-to-day tasks and responsibilities match your job title or job description? Isabel, if you want to start again.
Sure, I can just plan to be the first one in there. I think my official role is software engineer, and I do spend, I would say pretty much all of my time doing software engineering, especially if you say that writing documentation is software engineering, which I think people should. I think that has been pretty accurate for me. I am also pretty early in my career. I'm also doing a master's program. So I get to kind of dip my toes in a lot of different ponds. So I think for now, it seems to match what I expected.
How about you, Julia?
Yeah, I mean, it's kind of hard to tell. The job description is usually kind of ambiguous. So I know that about a year ago, I transitioned into something that was called like data analytics lead. And I expected it to be mostly using my statistical analysis knowledge, and then realized, oh no, I need to be able to write a lot of like functions and very well documented code, and I got very overwhelmed. So yeah, I mean, it is really hard to tell when you're reading the job description exactly what level of proficiency they're asking for. So I think that is an important part of the interviewing process, to be paying attention to the questions that are asked of you, and to ask questions of the people who are there to figure out the kinds of software that you're going to be expected to use, the level of proficiency that you need. Because the posted job description on Indeed or whatever is not always the most informative.
How about you, Jess?
I feel like I can speak to it as far as like the title data scientist in general. Since I don't know that I've ever actually seen a job description from my company. I was hired at a very early stage startup, so those didn't particularly exist. But I feel like I've always been the oddball data scientist. I can't tell you the last time I did a predictive model or like anything statistically informed. I do much more like data architecture at this point, probably closer to like data engineering. So I've always kind of had this mismatch, but it's also like data scientist is such a broad term. Everyone assumes when they get into this field that, yeah, I'll be building these like cool AI models or doing something really fancy. And yeah, most days you're going to be cleaning data like the rest of us and not doing anything super exciting. So yeah, there's a mismatch, but I'm content with that mismatch.
How about you, Marika?
The reason why I like analytics engineering is that is the specificity of it. Like when I started, there was really only like 2 roles. And it was data science. Well, there's data scientist, data analyst, and data engineer. And when I worked as a data scientist for a period of time, and because there wasn't really an analytics engineering, like you kind of end up doing it, because if you're the first data scientist at a company, like they're gonna want like what they'll call like, what was it? Machine intelligence. And it's like they got 50% of both. And what they need is BI, because for them to have usable data science products, they need to have a common understanding of data itself. And if they don't have that, then the data science products that you build, any sort of machine learning products you make, it's not going to make sense to them because they don't understand the underlying data or where it's come from or how it's generated. So I would try to like push in my own like NLP stuff because I just wanted to do it because it looked fun. But most of what I was doing was talking to the different people in the company and saying like, well, what do you want to know? How do you understand this now? And making sure that different teams actually had cross-team metrics that they use to determine determine success. So like, I think that's why I like analytics engineering, is that like, I'm not, the position's not going to get bloated. I'm not going to be I'm not going to be teased with the possibility of building some cool like model, but I'm going to build something that ensures that everything we build on top of our data is reliable and understandable and clear to non-data people, because I think that's what makes every other data product successful.
Okay. All right, next question. What is your advice for pivoting from less technical roles to more hands-on data science engineering roles?
I can go because I was an epidemiologist. I have a master's degree in public health that was really only useful when we had a global pandemic. So I think it's just that the best analysts I've ever met and the best data people I've ever met ask more questions than they make statements. And so asking a question is a superpower. It's a strength and it's not a weakness. So when you're in meetings with people and you're talking to new people, like ask an obvious question. Maybe other people aren't thinking about that or getting there, because you're getting everybody on the same page to start out with. So if you're pivoting to another one, and I think this is something that's more common with women than it is with men, that women will be like, I'm not an expert at Python, even though like, you've like built something in Python, and a man will be like, yeah, I've looked at it. I looked at Python code, and they'll be like, I'm an expert. And I think that's the difference. Is to some people, the tech itself is a tool to do something cool. And to some people, the tech itself is something that's fun to build. And so which of those is the best one for you? Pick that. But don't discount yourself. And also don't discount the power of not knowing something and trying to figure out how to do it. So sorry, that was a little rambly. I'm also trying to build something with Legos.
Isabel, did you want to also comment?
Yeah, I think the words were just taken out of my mouth. Asking questions is so useful, even if it's not from a less technical role to a more hands-on data science or engineering role, even if it's just a new product that you have to learn. It's really like anytime you have to learn new things, I think, one, don't be scared of the docs. They're normally written with lots of love, so you can hang out on them and learn a lot. Even though I read a lot of documentation, I tend to skim a lot of documentation too. And then I ask questions and then go back, and it's kind of an iterative process. So reading a lot, but don't be scared to ask questions, even if they're silly questions. Oftentimes everybody else in the room has silly questions too. So I think one of my favorite coworkers, he just walks into every meeting, and anything that is on his mind, like in the kindest way, he's willing to ask a question about, like, even if he thinks it's silly, and it opens the door for everyone else to have that same attitude, where it's not judgmental. Like, it's okay to ask dumb questions, and the more you do it, the more everybody else will too. And it has helped with communication on the team so much. to allow for everyone to do that, asking what they need and not just in a performative way.
Cool. Julie or Jess, do you have anything you want to?
I don't think so. Yeah, I mean, I don't even see that much of a distinction where I work between like technical and hands-on, but definitely echo all these sentiments about not being afraid to ask questions because other people have questions too.
Okay. How about how do you translate analytical findings to actionable steps to improve key metrics in your jobs? If there's a, I don't know, if someone wants to go first.
I'll pass this one off to someone who does more analytics. I can make up some gibberish, but I think there's more insight from others here.
I think a good key metric, maybe I'm just a broken record. I think a good key metric is not answering something. It's helping you ask a more specific question. So like, if we're doing like a long-term health thing and you build a dashboard or something and people from multiple groups are looking at this dashboard to determine if like things are getting better or worse, the dashboard is just going to show you a trend. It's like, it's not going to show you like, the dashboard's not you're not going to refresh and then it says better. That's not how it works. But that it's going to help you say, hey, this is weird. This one peak right here is different than it normally is this time of year. And it helps them ask a more specific question. And that makes them more curious about the data. And that also helps, guide whatever they want to prioritize it as working with. So, I mean, firstly, if you're working for a company that already has metrics defined, I mean, like, wow, congratulations, you have won the lottery. But the idea of what we would work on in those conversations is more like, how do we have a broad level of success and how do we represent that with data that doesn't necessarily give you an answer, but helps you understand your users in a more specific way.
So I work at an org that this literally sounds like every quarter's OKR planning. And generally I avoid this entirely like the plague. This language gives me terrible PTSD. But what I will say to this is like, the key is like really having a team that's willing to devote the time to defining what those key metrics are, because then the analytics you're doing to create the actionable steps, like it all just flows down from that. Like, you've developed something that can be moved, and then it's just about figuring out what levers to start to pull. But in order to do all of that, it's a really interesting, unique skill set and one I have no desire to develop, but knowing how to develop those KPIs and how to set up those OKRs so everything like streams down and is actionable and teams can have ownership over those things. It makes this sort of clearer in the process. The problem is I find a lot of orgs don't do that, and you have like this really vague sort of set of key metrics that you're like, how am I supposed to move that? That's so vague and nebulous. Like there's no way to sort of link the two. And that to me is more of a shortcoming in like creating the metrics than it is in like anything you're doing with analytics.
Okay. Julia, do you have anything to add?
I don't think I have anything to add because like key metrics, I think that's more like an industry or company term. So I have yet to come across it. I might in the future, but in the research world, it's just kind of all about like completing the studies that you've been assigned.
To jump off of what Jess said, and this is where my degree in public health actually helps, is when we define grant objectives, what you're actually supposed to do is have short-term and long-term objectives for the grant, like that they are actual specific objectives. Like we want to increase participation in the grant. We want to decrease this condition in the population. And then off of those, you have these SMART goals, which are measurable goals. You can't build those goals without first understanding the objectives. And I think that a metric, just to have a metric, is pointless. You have to have objectives first and then build the metrics. So a lot of times you'll talk to people who just want metrics, and you have to work backwards and say, well, what are your objectives? Like, what's success to you? One of the things that I have found useful is Google's Heart Metrics framework, which is really specific to UX, but it gives you like a matrix to fill out with stakeholders to kind of work backwards to say like, okay, our goal is to increase new visitors to our website by this much. And that's like to working backwards. Like if somebody is saying like, I want to know the number of page views for this visualization, that's to see if the redesign is a success. Like I said in the comments, like you can't say that an increase in page views is because of the redesign, because those could all just be people who went to the homepage and that's their first page view. So that was like, it wasn't because of the redesign, they hadn't been to there before. So like, I think really starting from objectives, making sure that they have a strong understanding of their short and long-term objectives. That was very rambly. I'm so sorry.
That's great. Thank you. Okay, how about this question from the chat? Do you have any recommendations for learning command line tools like Unix, Bash scripting? It seems like something that would be helpful for people to have an easier way to learn. If anyone has any recommendations.
I don't know if I have a specific like course or website, but I just started doing more things on the command line. You know, if I was trying to navigate between folders or something, like doing it on the command line instead of in a UI, doing Git on the command line instead of in the UI. I think that's an easy way to start. So it doesn't feel like you have to make your entire life worse to learn something new. And I actually find that now I am much faster by doing everything on the command line that way. So I'd say start by doing things that you are currently doing in UI on the command line and just see what happens.
I refuse to use tools for Git because and maybe they've gotten better, but there's always this like layer of abstraction of like, did I just commit? Like, did the commit message go through? And the command line is so very clear that I've actually done these things, because Git's one of those things that like, once you mess it up, it is 900% harder to fix. But if you just do it right the first time, it's so easy. But like git reset head and you're like, what is happening? How did I create 4 new branches? I don't know how this happened. So like if you use the command line, that's a lot easier. And I think the other thing is that like there are some art forms that are, you look at them and you're like, wow, that looks so easy. And then you do it and you're like, why isn't my body doing this? My head's telling it to do it, but it's not doing it. Like ballet, right? They look so light and fluffy. And then there are some things that look really hard, but they're just like 17 layers of something super easy and dumb. And that's what tech is. Tech is just like a bunch of very simple layers on top of each other. And if you kind of understand the layers, then it's not that bad. So I think that's the other thing that you have to consider when you're working on the command line. Like maybe it sounds like it's really hard and it's like, oh my gosh, I'm hacking the NSA. But tech is just like 17 super dumb things stacked on top of each other. So just learn the 17 things and you'll be fine.
I think for me too, also finding someone who knows a lot of tips and tricks on command line is so super helpful. Like I remember the first way I learned to like edit documents is through the Vim. I think I hate it. It's terrible. And then someone else who's way savvier showed me Nano, and I was like, oh my God, this is actually like delightful. There's no other way I would have stumbled across this. So definitely like finding people who are good at this stuff and pairing with them if you can at work, or just like reading through their code, any of that stuff, it helps a lot.
Okay. Does anyone have any good conferences to recommend?
PositCon. I don't know if that's too obvious here, or formerly known as RStudioCon. There's always great things in the Python world that often have multilingual tools. PyData is, they have in a lot of different cities, they have different conferences. So I would say PyData is something to keep ears out for. They always have awesome talks with just really great technologists.
Yeah, NormConf was what I was going to recommend. And DBT has an annual conference called Coalesce. And if you are interested in analytics engineering, join the DBT Slack channel. Like there are tons of jobs posted there. And since it's such a new field, like everybody is new to it. There's very few of us that have been using it for more than like 5 years. So it's easy to break in. Yeah, Coalesce is the big one, and join the DBT Slack, which you can very easily access by going to getdbt.com. I think it's getdbt.com.
Okay. And maybe our last question. How do you prepare for the vagueness of data science where you're going to work?
I feel like for me, it's just kind of about knowing what you bring to the table and what your strengths are, and having confidence in that. Because like I mentioned before, I feel like data science is always kind of this weird, really vague term that can mean anything from like the weird stuff I do to building these massive models to being more on like the BI world, or the first data scientist in a startup where you do kind of everything. I found as long as I kind of know what I'm good at and I know how I approach problems, you can kind of adapt and figure out the rest. I try not to stress about the specifics. And we mentioned before too, like it's so hard to tell from like job titles and job descriptions until you get in there and really see what's happening. And then you just gotta kind of trust the tools you have in your tool belt and go from there.
Yeah, agreed. It can definitely be very ambiguous if you're job hunting. But if you get to that point of actually like talking to people at the organization and going through interviews, I think it becomes a lot more apparent because they're going to ask you certain questions. You can ask them questions and figure out if it's really a good match or not.
Isabel, Marika?
My one piece of advice is you could work for a company that is curing cancer, but if you work with a bunch of jerks, your life is going to suck. So when you are going through an interview process or when you're looking at a company, like if it seems like people have their ego wrapped up in the work, they are going to be hard to work with because they won't collaborate on solutions. Their ego will be wrapped up in their solution being accepted, and you're essentially just there to execute it. So that's my biggest piece of advice is I've worked with people who had that it didn't matter whether I was correct. They already knew what they wanted and anything I said didn't matter. So if clearly you're like, don't like go work for, you know, like a company that's like killing orphans or something. But like, even though there's just, they're all really nice and I have half day Fridays. But like when you're talking to people, these are the people who are going to be making you feel like you're doing a good job or making you feel like you're doing a bad job. And if they're jerks, like your life is going to suck. So that's just the biggest piece of advice I can give you.
Yeah, I definitely agree. Finding a team that allows you to be curious and is okay with the fact that, especially in data science, everyone is always learning all the time. I think that's very important to have people who are like interested in learning about new things. If you're interviewing or talking to a team or an organization that says they have it all figured out all the time, like one, they're lying to you, and two, they're going to suck to work with. So I think an ounce of humility helps on either side when communicating with people. And it's definitely something that I would put as like a top priority for places I'd like to work for.
Okay, thank you. Very eye-opening. Thank you again, panelists. I think we're going to take a 5-minute break and then go to breakout rooms. But thank you for being here and answering all these questions.
I can share a timer screen if we want to. That way we can check out this timer and then we will all be back. Okay. Oh. And that'll give us time to do the breakouts. So people feel free to go get a drink, a snack, whatever. And then we're going to go into the breakouts with the idea that it'll be more like everybody unmute, everybody say hi, everybody like, you know, won't be recorded. Just like maybe if you have specific follow-up questions and things, we can do that in the breakout. Dorina, do you want to decide which